Alright, we have this question before us to solve. A machine of 20 kilogram mass is mounted on a spring and dampers. The total stiffness of the springs is 80 kilonewton and the total damping force is 130 newton seconds per meter. If the system is initially at rest and the velocity of 10 centimeter per second is imparted on the mass, write down the differential equation of the motion and its solutions, evaluating the constants. And we have to determine the displacement at time or t equal to seconds. Let's begin. Now, let's put down our data. We have the mass given to us as m, that is 20 kilogram. We have the stiffness of the material to be 8 kilonewton per meter, which is equivalent to 8,000 newton per meter. We have been given the total damping force, that is C, should be 130 newton seconds per meter, and also we have been given the velocity as 10 centimeter per second, which is equivalent to, or in meters, is 0.1 meters per second. Now, for a force damp vibration, the equation of motion is written as m d squared x over the t squared should be equal to the restoring force negative sx and the damping force negative c dx dt. Let's rearrange this to be 0. So we have m d squared x over dt squared plus c dx over dt, then plus sx, which is equal to 0, equal to the same thing. Now, we have been given the mass to be 20 kg, so we put there 20 kg dx squared x over the t squared plus our c, which is 130, so 130, then the x dt, then plus our s, which is 8,000 newton per meter, then x should be equal to 0. Now let's try to make the d squared x over the t squared coefficient be 1. So we'll divide through by 20. At this, we can see that yielding d squared x over the t squared plus 130, that would yield 6.5 dx dt, then this goes will yield 400 x, which is 0. This is actually the equation or the differential equation of motion of the system. Now we have to find the solution of this equation of motion, evaluating the constants within the equation or within the solution, sorry. For a force down vibration, The solution of each differential equation is written also as x equal e raised to the power mu tp or mu tp or mu t into bracket a cos square root of omega squared minus mu squared t plus b sine omega squared minus mu squared also multiplied by t. Now with this, we are supposed to find omega squared and mu squared. Now the omega squared, we know it to be s over m, and 2 mu is also known as c, which is the damping force over m, which is the mass. The s, of course, we know it, so omega squared becomes s, which is 8,000 divided by m, which is 20, and 2 mu is the c, which is 130 over 20. Right. So we have the omega squared yielding the 400 and 2 mu yielding 6.5. So we have our omega squared. We have to find our mu and the mu squared. So you have to divide through by 2 to get 3.25 as the mu. So we have our mu to be 3.25. If mu is 3.25, then our mu squared should be 3.25 squared, and that will give us 10.56. 10.5 to 10.5625. Good. Now, having gotten these parameters, you can go ahead and substitute them into this equation. So let's see what we can do. Right, our x now becomes e raised to the power minus mu. We know it to be 3.25, so 3.25, then t, with our a, which is one of the constants, then cos square root of our omega squared, which is 400, and our mu squared, which is 10.5625, all multiplied by our time t, plus our b, the second constant, sine of square root of saying 400 minus 10.5625 multiplied by time t. Right. With this, we can further reduce it as x equal e raised to the power 3.25t in the bracket a cos, now Square root of 400 minus 10.5625 should give you 19.73. Right, then C comes plus B sine 19.73 T. Good. So this is the solution. Now we have to evaluate the constants A and B. Right. So now we can then go ahead and equate this as equation 1. Now from the question, it says if the system is initially at rest, one of the key words you need to take note, and the velocity is 10 centimeter per second. That is one thing you must also take note. It means that we have to differentiate this solution to get the velocity. So how do we differentiate this to get the velocity? Right. So now let's write this and see. We have x equal e raised by minus 3.25 t in a bracket of a cos 19.733 t plus b sine 19.73 t. Now, this is one component of it, and this is another component of it. In differentiating this, we are going to use the product rule because this component and this component are multiplied. So how do we differentiate this? Our dx dt then becomes, in differentiating a product rule, we will differentiate one of the components, leaving behind the other components. Then we differentiate the second component, leaving behind the first component. So in this case, let's differentiate this, then leave this behind. So how do we do this? In differentiating e raised by negative 3.25, we get negative 3.25 t. Sorry, we get negative 3.25 e raised by negative 3.25 t. Then we maintain it by multiplying by the same second component of the equation. Then plus, we will maintain this first one we differentiated, which is the negative 3 e raised by negative 3.5 t, and then differentiates the second component, which is a cos 19.73 t plus b sine 19.73 t. If you differentiate this is what we get. A cos 19.73, A cos 19.73. If you differentiate this, you will get the 19.73 will multiply the A. Then if you differentiate cos, you get negative. So it becomes negative sine 19.73 t. So this becomes negative 19.73 a sine 19.73 T. Then plus, this is B sine 19.73 T. When you differentiate this, the 19, when you have to differentiate 19.73 T, which is 19.73, then multiply it by the B, because this is the B. Now if you differentiate sine, you will get cos, so you put on the cos, then you bring it out, so 19.73 into the system. So when you differentiate B sine 19.73 T, you end up getting 19.73 B cos 19.73 T. Right, so let's further simplify this. You get the x dt being equal to negative 3.25 e raised to negative 3.25 t in the bracket of a cos 19.73 t plus b sine 19.73 t. Then here we can factor the 19.73, which is common in the bracket here. That is 19.73. You can factor it out, multiplying by negative 3. E raised to negative 3.25 t in the bracket of the a sine 19.73 t plus b cos 19.73 t. Alright, once you factor this out, of course here should be negative. Right, we have this equation, and so this equation becomes the velocity of the system. Good. So we're going to write this here as the x dt equal to negative 3.25 e raised to power negative 3.25 t in the bracket of a cos 19.73 t plus b sine 19.73 t, then plus 19.73 t 19.73 e raised to the power negative 3.25 t multiplying negative a sine of 19.73 t, then plus b cos of 19.73 t. Good. We have this equation. Now from the first equation, which is this, from the first equation, we can then make this as equation 2. Let's say equation 2. From the first equation, and from the question given to us, so if the system is initially at rest, it tells you that t, the time is 0, and when the time is 0, that is, let's say at t equals 0, then our displacement is equal to 0. So when you have this as initial conditions, then in place of x we put 0, and in place of t we put 0, and that will yield us 0 equal to e raised to the power negative, the first equation, negative 3.250. Let me put from the first equation, in a bracket of a cos 19.730, then plus b sine 19.730. Therefore this becomes e raised to the power 0, and this becomes a cos 19.73 times 0. Of course we give it 0, just as negative 3.25 times 0 gave us the 0. Then plus b sine, of course 19.73 times 0 will also give us what? 0. Good. So we end up getting 0 equal to e raised to the power 0. Any number raised to the power 0 is actually 1. Then a cos 0 should give you 1. Then plus b sine 0 will actually give you what? 0. So with this we end up getting 0 equal to a times 1 is a cos, then plus b times 0 is 0. So we end up getting 0 equal to a, that is a equal to 0. Now we have been able to evaluate one of the constants, a, to be 0. Now we have to evaluate the second constant, b. Then we are done with the work. So how do we differentiate the constant b? Evaluate the constant b. Now from the question, when the system is at rest, that the initial condition that is initially at rest, our velocity was 10 centimeter per second, which is 0.1 meter per second. So our second condition becomes this: when the time was still 0, our velocity, which is of course v, is actually dx dt. Whenever you differentiate a displacement, you get a velocity, dx dt, because the displacement is actually dx, this. And so when you differentiate this, you get this, which is the velocity. And they're saying that the velocity is 0.1 meters per second. And so it means that we are going to substitute the velocity into the equation 2 to resolve or evaluate our second constant b. So dx dt here now becomes 0.1, which of course should yield us negative 3.25 e raised to the power negative 3.25, then 0, multiplying the a cos 19.730, which is t, plus b sine 19.730, which we call the t. This should give us 19.73 e raised to the power negative 3.250, multiplying negative a sine of 19.730 as the t, plus b sine, b cos 19.730. So we have our 0.1 giving us negative 3.25 e to the power negative 3.25 times 0 should give us 0, in the bracket of A cos 19.73 times 0 should give us 0, plus B sine this should give us 0, then plus 19.73 e to the power 0, which is this, in the bracket of negative A sine 0, which is the same, plus B cos, of course, 0. Now with this equation we get 0.1 giving us e raised to power 0, we know it to be 1, that is e raised to power 0 is 1. Then 1 times negative 3.25 will give us the same negative 3.25, right? Now cos 0 is 1. This is 1, and 1 times a will give us a, plus sine 0 is actually 0. Sine 0 is 0. So 0 times b should give us 0, plus e raised to power 0, we know it to be 1. So 1 times 19.73 will give us 19.73. Then in the brackets, sine 0 we know it to be 0, and 0 times negative a will also give us 0. Then plus cos 0 is 0, and cos 0 is 1, and 1 times b is actually b. So this we can further move on to get 0.1 giving us, since this is 0, we end up getting a times negative 3.25, and that will give us negative 3.25. Then this is also 0, then b times 19.73 will give us plus 19.73 b. This should be a, sorry, a should be explained on this, right? But we know a to be 0, and for that we get 0.1 giving us negative 3.25, 0 plus 19.73 b. Okay, so we have this, and I'm getting 0.1 giving us 0 times negative 3.25 give us 0, then plus 19.73 b. So end up getting 0.1 giving us 0 plus this will give us 19.73 b. We divide through by 19.73. With this we cancel that. 0.1 divided by 19.73 give us 0.005, which is equal to b. Of course, means that b is equal to 0.005. Alright, now that we have been able to evaluate a and b, we have our a being 0 and our b to be 0.005. If that is the case, we have our a and b, then the solution, which of course we know it to be this, we'll substitute the constant a and b into the equation to finalize our solution. So let's do that. We have our solution, which is x equal e raised to power negative 3.25t. Then we have our a cos 19.73t. then you have b plus b sine 19.73t. So our x becomes e raised to the power negative 3.5t. We know our a to be 0 cos 19.73t. Then we know our b to be 0.005 sine 19.73t. This will further give us e to the power of negative 3.25t. Then this, of course, becomes 0 plus this is the same as 0.005 sine 19.73t. So finally, our solution becomes e to the power of negative 3.5t equal to the 0 from the system. We end up getting 0.005 sine 19.73t. This is the solution of the differential equation evaluating the a and the b. Right. Now let's look at the second question. The second question, we have to determine the displacement of when t equal to 2 seconds. So the t equal to 2 seconds. This is our solution, and at the same time the displacement. Equation. So this is the displacement equation. So then the x becomes e to the power of negative 3.5t, then 0.005 sine 19.73t. Right, then at t equals 0.1, right? Let's check again. T to be 2 seconds, sorry, at t equal 2 seconds, our displacement x becomes e to the power of negative 3.25, sorry, 2 at the 2 seconds, which is the t. The t here becomes 2 because at t equal 2 seconds. This comes 0.005 sine 19.73 2 seconds. Alright. When you use a calculator, you end up getting x to 0.0001230 4.477 going. So this is meters, which of course becomes x equal to 1, 2, 3, 4, 5, 6. So it becomes 4.78 times 10 to the power of negative 6 meters. So this is the displacement at t equal 2 seconds. And this is the end of the problem. Right. So then the solution, sorry, the equation and the solution becomes the equation of differential equation is the squared x over the t squared plus 6.5 the x dt plus 400x equals 0. And the solution of this differential equation of this becomes x equals to e to the power of negative 3.25t in the bracket of 0.005 sine 19.73t. Thank you.